In this tutorial, we will introduce two discrete distributions, geometric distribution and hypergeometric distribution. First of all, the objective of this tutorial, we would like you to understand the property and condition necessary of geometric and hypergeometric distribution, so that you are able to calculate probability for geometric and hypergeometric random variable. What is geometric distribution? We let x be the random variable that models the number of trials until a success or failure. And we say x follows the geometric distribution. There are four requirements for geometric distribution. The number of trials is potentially infinite. There are only two outcomes for trials, success or failure. The outcomes are independent, and thus, the trials have the same probability of success. The probability mass function of geometric distribution is in this form. The graph of PMF with difference value of x is shown here. The cumulative distribution function of geometric distribution is in this form. The graph of CDF is shown here. The mean and variance of a geometric random variable x are in this form. The moment generating function of geometric distribution is in this form. It comes to the example. For the first one, suppose that a professor randomly selects a people who is still HK student on the street. The probability he success is 0.2. And what is the probability that he can find in the fourth select? To calculate the answer, we can use the PNF of a geometric random variable with p equals to 0.2 and 1 minus p equals to 0.8. And we can get answer that there is about almost 10% chance that the professor can find it in the fourth select. For the second one, what is the probability that he must select more than 6 people before he success? To calculate the answer, you can use the CTF of geometric distribution. It is easy to calculate by 1 minus p x less than or equal to 6. And we can get the answer is about 26%. For the last question, find the expected value and what is the variance. It is easy to calculate the answer by substituting the parameter in mean and variance formula. What is hypergeometric distribution? If we randomly select n items without replacement from a set of n items, and there are only two types of items to be selected, the probability mass function of this discrete random variable x is called hypergeometric distribution. The probability mass function of hypergeometric distribution is in this form, and x is a non-negative integer. The mean and variance of hypergeometric random variable x are in this form. To distinguish binomial distribution and hypergeometric distribution, it's easy to feel confused whether we use binomial distribution or hypergeometric distribution to calculate. The main difference of hypergeometric distribution is that it is sampling without replacement. It means the probability of success is not constant. It changes every time when we pick a sample from a small population. When the samples are drawn with replacement, the discrete random variable x followed by normal distribution. It comes to the example. For the first one, suppose the lake contained 1,600 of fish. 80 of them was tagged by scientists. They randomly catch 50 fish from the lake. What is the probability that 5 number of fish was tagged? To calculate the answer, we can just substitute the parameter to probability mass function of x. For the second one, let the random variable x denote the number of eggs in a 5-card head from a standard 52-card deck. Find the formula of the probability mass function x. As random variable x follows the hypergeometric distribution, we can substitute the parameter to the PNF of hypergeometric distribution and get the answer. Here are exercises are related to geometric distribution and hypergeometric distribution. Try to finish them to see how you understand the topic. This is the end of tutorial. Thank you for watching.